Okay, guys, so today's lesson is actually really straightforward. It's on scatterplots. So scatterplot is just another way to show data or to show data that you gather in an experiment. So if I wanted to construct a scatterplot using the information below, suppose the number of vehicles Y passing through an intersection X minutes past 7 is recorded for 3 days. And the data are shown in this table. Picture this like it's one big data table. They're just stacked on top of each other because there's not enough space for one big one. Okay, so if I wanted to plot this 0, 7 could just be used as a point, right? So I could plot that at 0, 7 would be right here, right? Okay, and then I could keep going by a 60, 27, 60, 27. 60 is about right here, and 27 is about up here, right? So what's happening here is a scatter plot is just showing all this data. 30, 17. I would just come down here. 30 is about right here, and 17 would be this point here. So each of these data points are showing different situations in this experiment, right? So you should be able to see a trend here, right? As the time past 7 increases, the number of vehicles increases as well, right? Which makes sense because 7 o'clock, 7 onwards is pretty much rush hour, right? Okay, and so it makes sense that you're going to have more and more vehicles. Now, this one up here is kind of an outlier, right? It's kind of out there. Okay, so that doesn't really go with the trend of the data. All right, but the rest of it pretty much goes in a smooth transition. Okay, now this one here too kind of seems like an outlier, but it'd be interesting to continue this experiment even further past 7, because right here, this is 91 minutes past 7. That's getting to be like 8:30. By 8:30, people are pretty much at work. So it makes sense actually that the number of vehicles would decrease after this point. So you might, if you continue this experiment, it's probably not just going to keep going up, up, up. It's probably going to go up and then kind of start to come back down, right? And then it might start to go up again at around 5 p.m., which is when the evening rush hour is. So you can see trends in data through a scatter plot, right? Now, an outlier is something that's really important. It's any point that does not follow the general trend of the data. So we had a couple outliers up here. We had an outlier up here, right? We had an outlier right here. Okay? Now, if all of the points are really close to one another, I would write these down if I were you. Okay, pause this video if you have to and write these down. If the points are all really close to each other and they follow a predictable trend, that's called a strong association. A weak association is when they follow a trend, but it's a little bit more spread out, right? And then no association is when it's just kind of a whole hodgepodge of points. So a good way to figure it out is if you draw a rectangle around your points, if you can draw a pretty skinny rectangle, then it's a pretty strong association. If your rectangle is big and fat, then it's a weak association. Okay, there is a metric to use. It's called R² values, but we are not really going to get into that in this class. So these are all positive correlations. A negative correlation would look something like this, where the points go downward. Okay, that's a negative correlation. Now, oh, and there's also this thing called linear and non-linear association. So this would be a linear association. And then there's also something called a non-linear association. And you guys can probably guess what that's going to look like. It's going to look like a curved line, like that. Okay? Or something like that. Okay. So the line of best fit. The line of best fit is the line that closely follows the linear pattern of the data points. Okay. Generally, half the data points should be above the line and half of them should be below it. Okay. So line of best fit is the line that goes through the middle of the data points. It does not connect the points necessarily. It might, if you have a really, really good association, it might connect them, but it doesn't have to. Okay. So let's say I have this data. So this is my data, and I plotted the data down here, and I wanted to draw a line of best fit for this data. Okay. Well, we have the rainfall is on the x-axis, and we have the number of accidents on the y-axis. Okay. So my line of best fit would probably go right here and go through the middle of the data. Now, if I wanted to figure out an equation for my line of best fit, I need the slope and the y-intercept. The y-intercept is maybe, I don't know, like 1.8, something like that. Let's say 1.5. 1.5 would probably be better, easier to work with. The slope, I'm going from 1.5 up to 4. So I'm going up 2.5, and I'm running over about 1.5. So it'll be 2.5 over 1.5. And so that's going to get me a slope of 5 over 3. I just multiply the top and bottom by 2. So that means my equation is going to be y equals 5 over 3 x plus 1.5. Right? So I figured out the equation for my line of best fit. And now I can actually use this line of best fit down here. Y equals 5 over 3 x plus 1.5. What does the slope and y-intercept of the line of best fit mean in this context? Well, the slope is telling me for every 1.5 inches of rainfall, there was about 2.5 accidents, right? Or for every 3 inches of rainfall, there's about 5 accidents. So the slope is telling me the number of accidents per inch of rain. Meanwhile, the y-intercept is telling me how many accidents. The y-intercept is telling me how many accidents when there are 0 inches of rain. So number of accidents when it doesn't rain. Again, if I'm going too fast, just pause and rewind. That's perfectly fine. Okay? Now, estimate the number of car accidents that will happen if it rains 5.5 inches. So I'm going to plug in y equals 5 over 3. But instead of x symbolizes my amount of rainfall. So I'm going to plug in 5.5 for x plus 1.5. Now I'm going to solve out for the number of car accidents. So 5 over 3 times 5.5 plus 1.5 gets me about, I don't know, about 10.7 car accidents. So 10, maybe 11 accidents that you can predict. What if there's 15 inches of rain? That's going to be 5 over 3 times 15 plus 1.5. 5 over 3 times 15 plus 1.5 gets me about 26.5 accidents. Okay? So you can use your data and your line of best fits to make estimates, right? And this might be good for maybe a city planner or a meteorologist or somebody like that. And now for this one, estimate the amount of rainfall there is when there are 5 accidents. That means 5 is going to go in for your y, because y symbolizes your number of accidents, times x plus 1.5. And now you solve out for your amount of rain, x. So you subtract 1.5 You get 3.5 equals 5 over 3x. Divide by 5 over 3. And you get x is about 2.1 inches of rain will result in 5 accidents. All right, I know I went through that fast. If you need to rewind, that's the beauty of videos. So feel free to do that. It's perfectly fine. Okay. And I will see you guys later. Have a good one.